part 3. If you didn't think you were afraid we haven't learned enough in 1.2 yet. Let's learn some more in 1.2, right? You wonder why I broke this up into 3 homeworks.
Yeah.
Could you imagine having to do all of this?
Nope. No. Oh, no. All right.
Now, here's the deal. It's all going to come together on the quiz. You know. But, okay. So, our first topic is even and odd functions. And as we talk about even and odd functions, we'll talk about how they relate to symmetry. Okay. This is where I always struggle. I think maybe we talked about even and odd functions in Algebra 2. I feel like we did. Okay. Not sure. I'm not saying it was a strength, but I feel like we did at some point. Maybe not. I don't know. Okay. So, even and odd functions. A function is considered even if one of 2 things is, well, if there's 2 different ways to tell. One way we know that a function is even if it is symmetric across the y-axis. Okay, what do I mean symmetric across the y-axis? Left and right side fold on top of each other, yes? Okay, so there is your option if you have a graph to look at. Is it symmetric across the y-axis? Now, I'm going to go back to, do we always have the graph to look at? No, you don't always have that option. So, algebraically, a function is even if f of x equals f of negative x. Okay, we'll talk about how to find that and check that here in a moment. But here's what I'm going to say coming out of this. Kind of like domain. What did I suggest on domain? Or when you're looking at removable and non-removable continuities. Yes, it's good to be able to use the graph, but I encourage you to use the algebra along with it, because sometimes the graph doesn't do everything for us. Does that make sense? Okay, so I'm going to encourage you to use a combo. Now, the other part of this today is a function is considered odd if there is what we call origin symmetry. Now, origin symmetry is, as you can guess, symmetric about the origin. But what does that mean? And there's 2 ways I can describe that. The easiest way, I look at it as it's kind of a double reflection. If something's symmetric about the origin, you can take, like I think of it in terms of like 4 quadrants, but you can reflect it across the y-axis and then also across the x-axis. So it kind of ends up reflected in a diagonal quadrant. Okay? Again, an example is going to be the best way for me to show that for it to make sense. But that's origin symmetry. I think if I have it correct in my brain, you can also think of it as like a 180 rotation. Is that right?
360.
Definitely not 360. No. Okay. Now, so that's a graph, and this is where, you know, why it's good to know the algebra too. A function is odd if f of negative x equals negative f of x. Okay, guys. I've given you the information. Now I've got to put it into play. 3 examples here. Tell whether each function is even, odd, or neither. And then, of course, it says also determine their symmetry. Now, don't graph yet. Got it? We're going to go the route of, we'll use the graph to confirm ourselves at the end. But I really want to stress, okay, how does the algebra work? So, in all honesty, I can tell you the answer just by looking at the equation because I do know what the graph of this is. As you should know what the graph of this is. Okay? So if you can visualize that graph in your head, and you can decide what type of symmetry it has, you've just completed the problem without doing any work. Okay? Now, how does the algebra work, though? I always start with testing even. And then if it fails the even test, then I test odd. Okay? And it'll make sense why I do this. The even test is, does f of x equal f of negative x? Well, what do we already know? We already know f of x. The question is, does f of x equal f of negative x? So, how do we find f of negative x? Every place I see an x, we're going to replace it with negative x. Does that sound familiar? You repeated before I even said it, like you kind of have heard me say that before. So, okay, so it's x squared. I'm going to replace that x with negative x raised to the second minus 3. What is negative x raised to the second?
Just x.
Well,
X squared.
X squared. A negative x times negative x becomes a positive x squared, yes?
Mm-hmm.
And minus 3? X squared minus 3. What just happened?
We got the same thing.
Okay. We just got equals to x squared minus 3. What was the original? X squared minus 3, yes? So we just found that f of x is equal to f of negative x. If f of x is equal to f of negative x, what test did we just pass?
It's even test.
This graph is even. Okay? You don't have to continue. If it passes the even test, you're done. You stop there. Now, if you were to graph this on your calculator, what graph are you getting? A parabola, yes? And officially, if you want to be official, it's a parabola that is moved down 3, yes? Well, what do we know about a parabola? It's just moved down 3. It's symmetric across the y-axis. What's the definition of even? Symmetric across the y-axis. So the question was, tell whether each function is even, odd, or neither. Also determine their symmetry. So this is symmetric across y-axis. Okay. Could you have done that problem by just looking at the graph? Absolutely. Does it always work like that, though? No, which is why I'm showing you both. In all honesty, come quiz time, come test time, I'm not going to tell you what to do. I'm going to say, is the function even, odd, or neither? Whether you test it via algebra, whether you test it via graph, is going to be up to you. My suggestion is going to be to use a combo of the two. Okay? Okay, you ready for the next one? This time we're talking g of x. Same idea. First thing I'm going to do is I'm going to test for even. Does g of x equal what? G of negative x. That's always the first thing I do. Because here's the deal. We haven't gotten to odd yet, but aren't we going to have to know g of negative x to test odd as well? Yeah, so we might as well get even checked out of the way first. So every place I see an x, I'm replacing with negative x. So instead of x to the second, negative x to the second. Instead of minus 2 times x, minus 2 times negative x, and minus 2. Okay? Negative x raised to the second becomes positive x squared. Negative 2 times negative x becomes positive 2x. And then we still have minus 2. What do I know at this exact moment? It's not even. Okay, I know that this did not equal g of x. Okay, so because these guys are not equal, I'm just going to, not that you have to write this in, but this is what my brain is thinking. My brain says, okay, cross even off the list. It's not an option. So now I'm looking at odd or neither. Okay, so continue. It failed the even test, odd test. Does f of negative x equal negative f of x? Or in this case, does g of negative x equal negative g of x? Well, what do we already have? We already have g of negative x, yes? Now we need to find negative g of x. What does putting a negative out front mean? We're going to take that whole g of x and multiply it by a negative. So here's how I'm going to show my step is I'm going to put a negative out front, and then in one set of parentheses I'm going to put x squared minus 2x minus 2. So basically when it's negative g of x, you take that negative and you distribute it to
Everything.
every term. So this is going to become negative x squared plus 2x plus 2. And that is negative g of x. Now, what do we need to be checking about negative g of x? Does it equal g of negative x? And it does not. So, what is my brain thinking specifically after this test? Well, before I go there, can we say it's not odd?
Yeah.
Okay, so that test specifically told me it's not odd. And then process of elimination. If it's not even, it's not odd, it is neither. Now, I didn't talk about this graph to begin with. What do you know this graph is? This graph is a parabola, but is it a graph that, like the last one, was just moved down 3 and is still centered on the y-axis? No. If you graph this, it's just a non-centered graph is what it is. What was it? X squared, is it minus? Let's see here. Minus 2x minus 2. So if you can see it. Okay. If that parabola was positioned differently, could it be symmetric across the y-axis? It could. But this graph is not positioned to be symmetric across the y-axis. So I know by looking it's not even. I know you haven't seen an odd graph yet. We'll get there. Okay, but if it's symmetric about the origin, you're going to have the same pieces of graph in up and diagonal quadrants. And right now, none of my quadrants really have the same pieces, if that makes sense. Again, I'll make it make more sense here in a moment. Okay? Okay, ready for C? Okay. They give me h of x. What's the first thing I'm checking? And we're not graphing yet, right? Okay. First thing I'm going to check is
Evens.
h of negative x to decide, is this even? And when you're doing it on your own, could you go straight to the graph? You could, but I don't want that. Every place we see x, put in negative. So x to the third is now the negative x to the third over 4 minus negative of x squared. Okay? And I know some of you aren't going to show this step out, and that's fine. Okay. Negative x raised to the third.
Negative x to the third.
Negative x to the third. Because when you multiply 3 negatives, you get a negative. Okay? 4 minus, what is negative x? You have to start with the power. What is negative x raised to the second? X squared. So this is 4 minus x squared. Because a lot of you said 4 plus x squared, didn't you?
Yeah.
Do you understand why it's not 4 plus x squared? This is not just minus a negative is a plus. This negative is being, first and foremost, is being raised to the power of 2. Now, if you still have a negative and you then go put them together, yes, we can say minus negative. For instance, if this had been 4 minus negative x to the third, well, first you would do negative x to the third and get a negative x cubed, and then that would become positive. Are we okay with that?
Yes.
Okay. So I have negative of x cubed over 4 minus x squared. What is your brain saying right now? Okay. These guys do not match. Okay. And so right now, my brain is saying not even. Even. This is a horrible place to end. And I looked at my watch right before the bell rang. I don't know if you guys saw that. And it was 10:13. And I'm like, oh no, how can I finish this up in a minute? Or like 2 seconds. We'll finish this up tomorrow. I'm not even going to try and rush through the explanation. You're my only pre-calc class. These notes will just sit here till tomorrow. Sorry. That was me not watching the clock at all.
Yeah, she like